product to sum and sum to product formulas. So in this section, we're going to introduce two sets of identity that enable us, on one hand, to write a product of factors of sine and cosine as a sum, and on the other hand, to write a sum of sine of cos and cosine as a product of factors. Okay? Let's start with the first set of formulas, which is product to sum formulas. Product to sum because they intertwine the product of sine and cosine to the sum of sine and cosine. Okay, and so you transition all the left side here as product between those strict functions, and everything on the right side is the sum or difference of those strict functions, sine and cosine. Okay, so all these properties hold for any choices of u and v. The first one reads as follows. So sine of u times cosine of v is equal to half the quantity, which is a sum of sine acting on the sum of the angles u and v, and the other entity is sine acting on the difference between those two angles u and v. Okay, and the rest are very, very similar. They all stem from the same source, and that source is the addition and subtraction formulas that we learned a couple of sections ago. Okay, so let's prove one of them, because all the rest are very, very similar. So let's prove the first one. Let's prove that one. So proof. Look, take a look at what's inside the brackets here. Okay, take a look at what's inside the brackets. What's the observation? The observation is that I have a sum between two things. Each one looks like sine acting on either a sum or a difference of angles. Okay, so clearly the sine or the addition formula for sine is going to be involved, and the subtraction formula of sine is going to be involved. How about we revisit these two formulas? So recall that for any u and v, we had sine of u plus v is equal to sine of the first angle, u, times cosine of the second, plus cosine of the first times sine of the second. Correct? So this is a formula we know. And out of this, if you remember, we also derived this one. So sine of a difference, which is sine of u cosine of v, minus cosine of u times sine of v. Agree with that? So this is something we learned before. How about now? So what do we need here? We are talking about the sum between this guy and this guy, correct? And this guy is this piece, and this guy is this piece. So apparently it looks like I'm adding those two guys. So I'm gonna add these two equations. Okay, adding, what do I mean by adding two equations? I mean I'm adding I'm adding those two sides, the left sides together, and the sum is gonna be equal to the sum of the two right hand sides together, right? So let's see, let's check this. So let's add them. What do I get? So what's this side? This is sine of u plus v plus sine of u minus v. Correct? If you add these two sides, you get this. Now, how about we add these two sides? What do we get? We get the top one, which is sine of u times cosine of v plus cosine of u times sine of v, plus the bottom one, right? The bottom one, this whole thing, this whole expression here, sine of u cosine of v minus cosine of u sine of v, right? So if we add these, this is what we get. And the quick observation is going to reveal the following. Well, cosine of u sine of v minus itself, that guy and that guy are the same, correct? And they have different signs, so these are going to cancel. And what do we get here? We get this plus itself, that these guys are the same. I mean, this sine of u plus times cosine of v and sine of u cosine of v. So I'm adding this to itself. So this is twice this expression, correct? So this is twice this expression. So that is to say sine of u plus v plus sine of u minus v. I'm copying this left hand side is equal to, as we said, that guy plus itself. So something plus itself is twice that thing, right? So we get this, right? How about now we contrast it with our desired thing. Look, just look at this and look at what we have. Just compare the two. What do you see? Well, this guy is the left side, and this guy is half of this right hand side. Okay, so we got the formula then. How do we get it? I mean, it just suffices to now divide by 2, as we said. It's that side was half the other, so this means, oops. So this means if you divide both sides by 2, we get half of this left side, u plus v, sine of u plus v, plus sine of u minus v is equal to sine of u times cosine of v. Correct? So we divide both sides by 2. This is what we get, and this is what we want. All right, so let me just put a period here. This shows the first identity above, right? Do you agree with this? All right, so this completes the first. I'm gonna leave the remaining 3 as an exercise for you, but let's talk quickly about it, about all the 3. The second looks like I'm gonna take the difference between sine of u plus v and sine of u minus v. These, we have formulas for each one. Actually, they are on the screen, right? So instead of taking a plus, I'm gonna take a difference. And if you take a difference, those guys now are gonna cancel, and what you're gonna get is cosine of u sine of v plus cosine of u sine of v. If you take the difference, right, the minus times the minus is gonna be plus. So these guys now are gonna cancel for the second one, and those are gonna add up. And I hope you see that if you continue the same way as before, you're gonna get exactly that second identity, correct? Because you see cosine u sine v, you add them up, you get twice cosine u sine v, and then you divide by 2 as we did for the first one. Okay, I encourage you to complete the other 3. The third one is you're gonna add the addition formula for cosine with the subtraction formula for cosine. Okay, so add these up exactly as we did here, but instead of sine of a sum and sine of a difference, you're gonna have cosine of a sum and cosine of a difference. Once you add them up, you should get this, and once you take their difference, you're gonna get this. Okay, so anyway, so this is my discussion about these 4 formulas. Let's put them in action now. Let's go to the book, and let's go to page 605. This is section 5.4, and let's do a couple of problems from this group from 3 to 10. So we're gonna write the product. Everything here is a product of sine cosine. We're gonna write a product like this as a sum or difference. So what we just did just before. Okay, let's do number 4. So I want to write this product sine of negative 2 theta times sine of 4 theta as a sum or a difference. So problem 4 on page 605. So we're gonna write this product, so sine of -2 theta times sine of 4 theta as a sum or difference. So this is sine times sine. Okay, so let's go back to the formulas we have. This is sine times sine. Where do we see sine times sine on the left side? Well, it's the last formula. It's this one. How about we copy it and take it with us? So how about we copy this and take it with us? Let's take it here. So I'm gonna apply this formula. I'm gonna apply this formula in this problem. And how am I gonna apply it? So sine of u times sine of v. So apparently the u is the -2 theta, correct? So apparently, so I'm gonna use that one. I'm gonna use this formula with u being -2 theta, right? This is my dictionary in this context. That -2 theta is the u, and that 4 theta is my v. And I'm gonna rewrite this with these choices of u and v. Okay. Let me actually change the color of this guy to be all green. Let me make it smaller. Okay, so we're gonna apply this. We're gonna apply this right here, right? And as we said, the u is gonna be -2 theta and the v is gonna be 4 theta. So as such, I can rewrite this product as -12 times the quantity cosine of u plus v, cosine of u plus v, and the u is -2 theta, plus the v, right? And the v is 4 theta. Agree with this? I'm just applying this. Minus cosine of the difference between u and v. And the difference is going to be -2 theta minus 4 theta. And we have the parentheses and a bracket. All right. And now obviously we can simplify a little bit. We get -12 times cosine. What's -2 theta plus 4 theta? So what's -2 theta plus 4 theta? This is 2 theta. This is 2 theta. And how much is -2 theta minus 4 theta? This is -6 theta. Agree with that? Okay, so as such I get -12 cosine of 2 theta here minus cosine of -6 theta. Okay, remember the question? The question was to write this product as a sum or difference, and we just did this. The only thing I'm gonna do is that I'm gonna apply that cosine as an even function to kind of like cancel this minus, even though this is a correct answer, because we answered the question. The question is to write the product as a sum or difference, and we did that. Okay, so the last thing I'm gonna do is I'm gonna rewrite this as -12 times cosine of 2 theta minus cosine of 6 theta, because cosine is an even function. Okay, let's go back to the book. Let's do another problem like this. So we did 4. How about 10? Cosine of 5x times sine of 2x. So number 10. Cosine of 5x times sine of 2x. So we're gonna write this product as a sum or difference. So this is a product between cosine acting on an argument, on an angle, times sine that's acting on some other angle. So cosine times sine. Let's see which formula handles this. So cosine times sine. It looks like the second one. It looks like the second one. So I've taken this with us below. Okay. So let's use that here. Okay, so who's gonna be our u, who's gonna be our v? So apparently the u is gonna be the 5x, and the v is gonna be where, the v is gonna be, the sine is acting on v, so the v is gonna be 2x, correct? So apparently I'm gonna use this as usual with u being 5x and v being 2x. Okay. All right. So I'm gonna put this in action here. I'm gonna use it, and I'm gonna get negative half times, no, sorry, 1/2, not negative, 1/2 times sine of u plus v, and u in this case is 5x and v is 2x, so sine of 5x plus 2x minus sine of the difference, so minus sine of the difference, which is 5x minus 2x, right? So we get this. All right, and can we simplify any further? Yes, we can add these two angles, so we get 1/2 times sine of 7x, correct? 5x plus 2x is 7x, minus sine of 3x. Agree with this? All right, and this is, we wrote this product as a difference. If you want to distribute the multiplication over subtraction, you can also write, but this is not necessary, obviously, half sine of 7x minus half times sine of 3x. It's up to you if you want to write it as such. Okay. All right. Let's go to the next group of problems. Let's do one from 11 to 14. The question is, use a product-to-sum formula to find the exact value. Let's do 14. Cosine of 25 pi over 24 times sine of 17 pi over 24. So 25 pi over 24 is certainly not a remarkable angle. This is pi because the reference angle here is pi over 24, right? Because 25 pi is 24 pi plus 1 pi, and this means the reference angle here is pi over 24, which is certainly not a remarkable angle, and likewise 17 pi over 24. So I cannot find cosine acting on this, sine acting on this without the use of a calculator. Okay, and certainly here the question is not to use a calculator. That's why they told us to transition from a product to a sum. If we transition to a product to a sum, we're gonna see on the sum side, we're gonna see angles which are remarkable. Okay, and then we don't need the calculator, so we get to find the exact value. All right, the calculator, remember, it doesn't give the exact value except if we have some nice numbers. If the number is crazy, so the calculator is going to give you an approximation of the number, because it's going to truncate the decimal numbers, right? So the numbers after the decimal point, after a certain, it depends on your calculator, but it's going to truncate it at some point. So it's going to miss a huge chunk of those decimal points. So it's not going to give the exact value. That's my point. All right, so let's take 14, use one of the product to sum formulas, and see what these guys are gonna give us. Okay, so this is problem 14, and we have cosine of 25 pi over 25 pi over 24 times the sine of 17 pi over 24. Okay, so here I still have cosine times sine, so I'm gonna still have this formula that I just used in previous example. So how about we take it, copy it, and paste it here. Okay, let's make it bigger, and let's choose a different color for it. How about this color? All right, so we're gonna use that, as we said, we're gonna use that, but now with what are the choices of u and v? Well, the u is the guy that cosine is acting on. It's the angle that cosine is acting on. Well, cosine is acting on 25 pi over 24 here, so this better be the u then. And the v is the angle that sine is acting on, correct? And the formula. So it's going to be 17 pi over 24 here. So this is my package of ammunition in some sense to actually tackle this question. And what do I get? I get half of sine of the sum of u and v. So sine of 25 pi over 24 plus 17 pi over 24 minus sine of the difference between u and v, so sine of 25 pi over 24 minus 17 pi. Okay, I don't like this. How about I make it actually smaller? Actually, how about I move it here? So minus 17 pi over 24, right? So I get this. All right, and what's 25 pi over 24 plus 17 pi over 24? Well, we have the same denominator, so this is 25 plus 17 pi, and what's 25 plus 17? It's 42 pi over 24, right? And if we simplify, what's the largest divisor here? 6. If we divide by 6, we get 7 pi over 4, right? So what I've done here is I divided by 6. 42 divided by 6 is 7, and 24 divided by 6 is 4. Okay, how about this? What's 25? This is also the same denominator. I'm taking the difference of the same entities. 25 minus 17 is 8 pi over 24. And if you divide by 8, we get pi over 3, right? We get pi over 3. Makes sense? Okay, so then this whole thing is equal to what? Then this is equal to half sine of the pink one, which is 7 pi over 4, minus sine of pi over 3. Okay, so we have this sine of pi over 3. Pi over 3 is certainly a remarkable angle. What's sine of pi over 3? Well, this is square root of 3 over 2, correct? All right, and 7 pi over 4. 7 pi over 4 is an angle in the fourth quadrant. Am I correct? Because you can think about 7 pi over 4 as, right, 7 pi over 4 is equal to 2 pi minus pi over 4. Agree with me? Because this is 8 pi minus pi over 4, and 8 pi minus pi is 7 pi. So it's in the fourth quadrant, and its reference angle is pi over 4. Agree with that? So pictorially, what I'm saying is this. So if this is the plane, that's the angle, 7 pi over 4. And as such, the reference angle becomes pi over 4. Agree with this? All right, so then what do we get? Then we get that this is half times sine of 7 pi over 4 is going to be the same trig function, sine acting on that reference angle pi over 4, right? I'm talking about this, but the question is, which sign is it, plus or minus? Well, the sign here is negative, right? The sign of this guy is negative, so it's gonna be minus. So that guy is gonna be minus. One more time. If you remember, trig function acting on an angle is equal plus or minus, which is to be determined. The same trig function, in this case I have sine, acting on the reference angle, which is pi over 4, right? Remember, the reference angle is the acute angle between the terminal side and the horizontal axis, correct? So it's pi over 4 in this case. Okay, so the question becomes, is it plus or minus? This is determined by where this initial angle is, in which quadrant, where it lives. It lives, in this case, in the fourth quadrant, and the sine of an angle on the fourth quadrant, is going to be negative, right? So this is why it's the minus sign. Make sense? Okay. Minus, so I'm talking now about this guy, minus this entity, which is square root of 3 over 2. All right, and this is now, this is a reference, obviously this angle, the reference angle is remarkable, so I know what this guy is. Actually, let me write it here. What's this piece? That's square root of 2 over 2. So this becomes then equals half times minus the square root of 2 over 2 minus the square root of 3 over 2. Yes? And if you put them together, you get this is over 4 with a minus sign, square root of 2 plus square root of 3 upstairs, right? So I factored out negative, I got it here, and then I add them up. This becomes square root of 2 plus square root of 3 over 2, and then multiply the 2 with the 2, you get the 4. So that entity, that quotient, is the exact value of cosine 25 pi times sine of 17 pi. Sorry, cosine of 25 pi over 24 times sine of 17 pi over 24. Okay. All right. Let's do one from this groups, 15 to 18. And let's choose, how about 18? It looks probably a little complicated. How about 18? So I want to show that twice the sine of pi over 4 plus x minus y over 2 times cosine of pi over 4 plus x plus y over 2 is equal to cosine of x minus sine of y. All right. So that's 18. And I want to show the identity, which is twice sine of pi over 4 plus x minus y over 2 times cosine of pi over 4 plus x plus y over 2 equals to cosine x minus sine of y. Okay, this is for any x and y. All right, so how can we show this? What should we use? Well, look at the nature of the left-hand side. It's a product, right? It's a product between sine and cosine. And what's the nature of the right side? It's a difference between cosine and sine. So it looks like I'm transitioning from product of sine cosine to a sum, or difference in this case, between cosine and sine. And do we have a property that can handle this, that allows us to pass from one side to the other? Yes. I mean, let's go back to the first page. And which one is it? So I need a combination between sine cosine, so it's the very first one, sine of this of u times cosine of v, and I have this side, correct? So I have it in terms of a sum between sines. We're gonna see how we're gonna get the other part later. And by the other part, I mean the nature of the right-hand side. The nature of the right-hand side in our context is what? Cosine of x minus sine of y. So where does cosine come from? You're going to see in a second. But at least I know how to start moving from left to right. I need to transition from sum, sorry, I need to transition from product to sum. Okay. So using the very first formula that I just showed you, namely, let me write it again here. So let's use sine of u times cosine of v, and the formula says it's equal to half sine of u plus v plus sine of u minus v. Okay, so we're gonna use this, and we're gonna use it with what? We're gonna use it with what? U is the angle that sine is acting on. Well, sine is acting on this entire thing, so u is gonna be that thing then. So pi over 4 plus x minus y over 2, and the v is what cosine is acting on, right? What cosine is acting on, and cosine is acting on this guy. So pi over 4 plus x plus y over 2. Agree with that? So I'm going to use this to transition from that left-hand side. So left-hand side is equal to, because of this bubble that we, or this cloud that we just talked about, we can write this as 2 times, this 2 is still there, 2 times the half, right? So the half is going to come from this product, so 2 times this half times the bracket sine of u plus v, so sine of u plus v, right? U plus v. How about we actually take this u plus v and add them on the side, just by themselves. So how about now we add for this u and for this v, how about we actually find what u plus v is and what u minus v is. Okay. Why? Because I need them here, right? So just to isolate this computation. So what's u plus v? Well, u is this much. And v is this much. Agree with that? All right, so pi over 4 plus pi over 4 is pi over 2, right? Twice pi over 4 is pi over 2. Plus, if you add these guys, they have the same denominator. X minus y over 2 plus x plus y over 2 is the sum of these numerators over 2. Well, x minus y plus x plus y, the y's are going to cancel, and you're going to get 2x over 2. Right? Because negative y plus y is 0. So x plus x is 2x over that common denominator 2. And 2x over 2 is x, right? So that's pi over 2 plus x then. Okay. Can you find what u minus v is? The only thing is going to be that I have a minus here, right? So I'm going to have pi over 4 plus x minus y over 2 minus pi over 4, but now it's going to be minus for the entire v, right? It's going to be for the entire v, so it's going to be like this, right? Do you agree with that? Because that whole thing is u and that whole thing is v, so I'm going to take u minus the quantity v, it's going to be the whole package. And what is this? Well, the pi over 4, okay, you know what? Let's take a couple of steps. So pi over 4 plus x minus y over 2 minus pi over 4 minus x plus y over 2. Do you agree with, at least with this? What did I do? I brought this minus inside in some sense, right? So if the minus how do you destroy the bars in this context? Everybody inside flip signs. Pi over 4 is going to become negative pi over 4, and this quotient is going to be the opposite of the quotient. Okay. All right. Pi over 4 minus pi over 4, that's 0. So that's 0. How about the rest? So let's write them on the same denominator first, just 2. And what do I have? I have x minus y, this numerator minus this numerator, right? So it's that numerator minus that numerator, so I get this. How much is that? Still over 2. This is x minus y minus x minus y, agree? So again, for the same reason, I destroy the parentheses, this minus kicks in, everybody inside flip signs, minus x and minus y. Now the x and the negative x, they cancel. So this guy and this guy cancel. And what am I left with? I'm left with negative 2y over 2. Negative 2y over 2, which is negative y, right? So how much then is u plus v? It happens to be pi over 2 plus x. How much is u minus v? It happens to be negative y. Okay, so I'm gonna put all of these here. I'm gonna use those results, and I get, remember here we had 2 times all of this, right? 2 times all of this, and we used this property at the time, so we were applying it. So half times the bracket sine of u plus v. And what's u plus v? U plus v is pi over 2 plus x. So this is pi over 2 plus x, and plus sine of u minus v. Sine of u minus v. And what's u minus v? U minus v is negative y, agree? We did the computation. So negative y. Okay. All right. So all this package was needed over here, correct? So all this computations and discussion was needed over here. We move to the side, and what is that? How about I put here dot 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 and pick it up right there. So this is equal to 2 times half, that's 1 times sine of pi over 2 plus x, sine of pi over 2 plus x, plus sine of negative y. Let me copy it for the moment. Plus sine of negative y. All right. Keep an eye on what you want. What we want is cosine x minus sine of y. We need cosine x minus sine of y. Well, sine of pi over 2 plus x, if you use, either you use that cosine is a cofunction of sine, or you can use the addition formula for sine. Sine of s plus t is sine of s cosine of t plus cosine of s sine of t. Correct? You can use that. And if you use it, you get that this is equal to cosine of x. Correct? So if you use, again, either you use that sine and cosine are cofunctions, or you can use that sine of a sum, or you go back to the sine of a sum. So the addition formula for sine. Sine of a sum, s and t, is equal to sine of s cosine of t plus cosine of s times sine of t. So that's going to give you cosine of x at the end of the day. And this is equal to, how about this guy? This is equal to what? This is equal to negative sine of y. And why is that? Since sine is odd, right? So since sine is an odd function, sine of negative y is equal to negative sine of y. Yes? Okay, so at the end of the day, we get that this is equal to cosine of x minus sine of y. All right, as desired, which is the right-hand side. Okay. All right. I still feel that I should explain more this just in case someone is questioning it. Let me take my time to fully explain it. So this guy is equal to by the sum or the addition formula for sine, right? Again, you can either use what I'm using, or you can use cofunction formula. It's up to you. So I want to use this just for you to be able to, play around with these formulas, these identities that we have. So sine of s plus t is equal to sine of s, so sine of pi over 2 times cosine of t, which is x in this context, plus cosine of pi over 2 times sine of x. Am I correct? Yes. All right. Sine of pi over 2 is 1. This is 1. This guy is 1. So here I get cosine x, and this is 0, right? Cosine of pi over 2 is 0, so this product is 0. So I'm left with what I just said before. So I'm only left with cosine of x, because it's 1 times cosine of x, which is cosine of x, plus 0, right? 0 times whatever this number is, it's 0. So we get this. Okay. So that's why I was able to do this. All right, so this shows the identity in number 18. Next, we're gonna move on to the other set, as I promised you at the beginning of this section. So we have 2 sets of identities. The first set is what we just talked about at the beginning. The first set of identities, which has to do with writing a product of factors of sine and cosine as a sum, right? Now we're gonna go to the other set, which is backward. Now we're gonna write a sum of sine and cosine as a product of factors. Okay, so this is the next set of identities. It's right there. Okay, let me zoom in for you. You can see it better. So we have it like this. Okay, they look complicated, and this is too much, and so on. But look, this is nothing but the previous identity, the previous set of identities. Let me convince you. So for instance, we had, so let's prove one of them. So we had, and let's prove the first one, okay? Just because it's located at the very top. We had the formula, which is ProductToSum, like this. Sine of u times cosine of v is equal to half sine of u plus v plus sine of u minus v. Correct? So just compare this to this. What can you see? On one side I have a sum, on this side I have a sum. On the other side I have a product, and this side I have product. It looks like these sides are, these guys are the same as this, but they're swapped, correct? Which is no problem. So technically what I'm saying is that if you take this guy to the other side, right? So you take this guy to this side, and you take this guy to that side. Now compare the two. What can you see? They're almost the same. Okay, probably you can argue that half is different, but look, this is a sum of the two sine functions. This is a sum of 2 sine functions, right? And except for the 2, because I can move the 2 by multiplying by 2 here, right? By multiplying by 2. And the nature of this right side, is what? Is still product between sine and cosine, which is very much the same as this. Yes? And as I said, don't worry about the half, because if you multiply by 2, let's actually write it. If you multiply by 2, you get sine of u plus v plus sine of u minus v is equal to 2 times sine of u times cosine of v. Again, what did I do here? I multiplied both sides by 2. Okay, so you're allowed to multiply an equation by a non-zero entity and pick up an equivalent equation. This is what I've done. Why I did this? Because now we can see it. Now this is closer to that. Okay, this is as close actually as we can get to. This side is a sum of sine and sine. This sine is a sum between two sine functions. This side 2 times the product between sine function and cosine function. This is 2 times product between sine and cosine. Correct? So so what can you say? Who's u, who's v? This is a formula we know, right? This is a formula we know. And this is the formula we want. So who's u and who's v in our context? The u apparently is the x plus y over 2, and the v is the x minus y over 2. Or equivalently, the u plus v looks like it's x, right? I'm talking about the sine on the left-hand side here is acting on this angle, and the sine of this left-hand side is acting on this angle. So it looks like x is this guy. And this guy here, which is the other sine function acting on, is equal to that guy. So u plus v apparently is x, and the y is u minus v. Makes sense? Okay. So if we choose, so if we let u plus v to be x and u minus v to be y, what can you say about x plus y? What can you say about x plus y? Well, x is u plus v and y is u minus v. If you add them up, you get 2u, right? You get 2u. So what can you say then about x plus y over 2? What can you say about x plus y over 2? It's going to be half of x plus y, which is half of 2u. So it's going to be u then. Correct? And we know that x minus y is how much? With this x, with this y. If you take the difference now between x and y, if you take the difference, it's going to be u plus v minus u. So minus the quantity u plus v, let me write it. So x minus y becomes u plus v. This is the x guy minus the y guy, right? The y guy. And the y guy is u minus v. And what's this difference? This is u plus v minus u plus v, correct? Which is equal to twice v. So what's x minus y then? It's twice v. So how about half of x minus y? Half of x minus y, or x minus y over 2. Well, half of this is going to be half of this. And what's half of twice v? It's v. Okay? So my point here is, after we made the observation that this structure here looks like this structure, now we assigned roles for x, or for u plus v, and a role for u minus v in terms of the given x and y. And we found that if you add x and y, you divide by 2, you get u, and if you add, or you subtract x and y, you divide that result by 2, you get v. Correct? Now how about we rewrite this, let's give it a name. How about now we rewrite this equation, call it star, with these choices of u plus v and with these choices of u and v. Okay, so with these choices of u and v. So what do we get? We get, so thus star becomes sine of u plus v. And what's u plus v in terms of x and y? It's simply x. So this becomes sine of x plus sine of u minus v. And what's u minus v? What's u minus v? It's y, right? It's y. So plus sine of y equals twice sine of u, right? Sine of u. And what's u? Is the sum of x and y over 2 times cosine of v, and v is how much? V is x minus y over 2. So cosine of x minus y over 2. And it's not hard now to convince you that as what I was saying is correct, that this equation now is exactly this, right? I mean, let me try to put it on one screen here. See this? Sine of x plus sine of y, sine of x plus sine of y is equal to twice sine of the sum over 2 times cosine of the difference over 2, right? It's the same. So what I was alluding to before is that even though these look different, these identities look like a different set, at least the first one, because we took the time to discuss it, it looks like a different identity than what we had before, but this is exactly what we had before. Because what we had before was this, right? Product to sum was this identity that you see now on the screen over here. This is the product to sum. And now if you unravel, if you just manipulate it a little bit, you multiply by 2, you get that star equation, which is the same as this highlighted one. And if you assign up an appropriate choice of u plus v and u minus v, you get exactly what this property is saying. So that first property or this first identity is nothing but the old one, but specialized. And by specialized, I mean I chose certain, I picked up a certain choice for u and v, right? So technically I used u to be x plus y over 2, and I chose v to be x minus y over 2 in that highlighted equation, or that star equation, which is equivalent to this highlighted one. Okay. Anyway, so I'm just telling you that these identities are the same as the previous one, but now written sum on one side, transitioning to a product on the other side, right? Everybody here is sum or difference, and everybody here is multiplication, product of sine and cosine. All right, so let's apply these properties. Let's go back to the book, and now we're going sum to product. This is the second objective of the section. How about 22? How about 22? So I want to write each expression as a product. And this expression is cosine of 20x minus cosine of 14x. So this is number 22. Let's zoom in. So 22. I want to find, I want to rewrite actually this expression as a product. Okay, so this is cosine of something minus cosine of something else. So what's that property that allows me to go from this difference between two cosine functions to a product? It's got to be one of these. So which one is cosine minus cosine? It's the very last one, correct? It's that one here. Okay, so as usual, let's copy it. And let's take it with us to this problem. Okay, so I'm gonna use this formula I'm gonna use this formula, and I'm gonna use it with what? I'm gonna use it with what? What's the choice of x in this identity? What's the choice of x here in this identity? Well, x in my formula is the angle that cosine is acting on. Who's that angle that in my current situation or my current context that cosine is acting on? It's the 20x. Okay, so 20x is gonna be my x in the formula. Make sense? So the x in the formula is the 20x in my situation, in my context. And who's the y in my formula? Right, this is the recipe, this is the formula. Who's my y in the formula? It's the 14x in my context, right? So y is 14x in my context. So that's what I'm going to be needing here. And what do I get? What do I get? Well, I get minus 2 times sine of x plus y over 2, right? X plus y over 2. So x plus y is 20x plus 14x over 2 times sine of the difference between x and y. So the difference now is 20x minus 14x, because the x of the formula is 20x and the y of the formula is 14x over 2, right? Okay, so this is a product now, which is good. And then this is equal to what? Negative 2 times sine of 20x plus 14x, this is 34x. 34 over 2 is 17x times, so 17x is the argument inside sine, the sine function, times sine of 20x minus 14x, that's 6x. 6 over 2 is 3, so 3x, like this, right? So cosine of 20x minus cosine of 14x, that expression is exactly the same as this expression, but this is written as a difference and this is written as a product. Okay, so no matter what x you choose, these two are the same. Okay, all right, let's do more problems on this. How about one from 23 to 26? And let's choose the last one, 26. Cosine of 23 pi over 12 plus cosine of pi over 12. Again, 23 pi over 12 is not a remarkable angle. 5 pi over 12 is also not a remarkable angle. So I don't know how to find these, except I can approximate it by using the calculator. But if you want to find the exact value, we gotta do something else. And the something else here is they already told us, use SumToProduct. So here it's a sum. If you write it as a product, then somehow the new angles are gonna be remarkable. Okay, let's see. So as we said, this is 26. And we have cosine of 23 pi over 12 plus cosine of 5 pi over 12, right? All right, so cosine plus cosine in this context, cosine plus cosine, what's a formula that can handle this? Cosine plus cosine, that's the formula we're talking about, right? That's the formula. It's the sum of two cosine functions. So copy it, and let's take it with us to our problem over here. Okay. All right, so let me change the color again. Let's use orange for this, and then I'm gonna use that. Oops. So I'm gonna use that with our choices of x and y. So the x in the formula is what here? The x in the formula is the angle that cosine is acting on. So who's that guy in this case? It's 23 pi over 12. I mean, in this case, cosine x plus cosine y, the x can be any actually of the two angles, and y can be any of the other, not any. So the y has to be the other one, right? Because it's addition is commutative, so it doesn't matter which one you choose as x, as long as the other one chooses as y. Okay, how about x being 23 pi over 12, and the y being the other one, which is 5 pi over 12. Okay, so I'm using this, and let's see what we get. Apparently I'm gonna get two remarkable angles here. Let's make sure. So the formula tells us this is twice cosine of x plus y over 2. X plus y over 2. Well, x is 23 pi over 12. The y is 5 pi over 12 over 2, right? X plus y over 2, I get this, right? And times cosine of the difference over 2, so times technically the same one, right? Technically the same one, but now I have a difference, so just to save some time, you get here minus, correct? So cosine x minus y over 2, same thing. All right, and what is this? What is this? 23 pi over 12 plus 5 pi over 12. This is the same denominator upstairs. This is the same denominator upstairs. So that thing is equal to 23 plus 5 is 28 pi over 2. Over 12, sorry. Over 12. 28 pi over 12. Agree with that? Okay. Can we simplify here? Can we simplify? Yes, we can simplify by 4. If we simplify by 4, we get 7 pi over 3. If we simplify by 4, we get this, right? Okay, so this becomes then equal to, so 2 times cosine of, we found 7 pi over 3 upstairs, and that thing is over 2, right? That thing was over 2 times, so times cosine of the other angle. Let's find this guy. Let's find this guy. What's this guy now? 23 pi over 12 minus 5 pi over 12, same denominator. 23 pi minus 5 pi is 18 pi over 12, right? And if you simplify here, say by 3, if you simplify by 3, we get 6 pi over 4. And if you actually simplify it by 2 again, okay, I could have simplified here by 6, okay? If you simplify by 2 again, you get 3 pi over 2, okay? You get 3 pi over 2. If you simplify by 6 immediately, you're gonna get the same thing, obviously, okay? All right, so then this is equal to cosine of 3 pi over 2 divided by 2, correct? It's that green part, which is 3 pi over 2 divided by 2. Okay. All right, and what is this? 2 times, we need to simplify this writing in each one of them. And in each one of them, let's focus on the structure. Well, the structure in both of them is as follows. The structure in here looks, in each one of them, it looks like A over B, the whole thing is over C, correct? So I'm dividing the quotient A over B by C. And this is the same as All right, and this is this. Okay, I'm dividing then a over b by c, and this is the same as multiplying a over b by 1 over c, right? Division and multiplication are intertwined the following fashion. If you divide by something, this is the same as multiplying by the reciprocal of the thing, right? So we get this. And what's that? This is a times 1, so product of quotients is the same as the quotient of the product of the numerators divided by the product of the denominators, right? A times 1 over b times c. Yes? So that's what I'm gonna need. I'm gonna use it twice, first for this and second for that. Okay, so I'm getting cosine of, remember that's my a over b over c. A over b, the whole thing is divided by c. It turns out that this is a over the product bc. So that's my a, so 7 pi is my a, divided by, here the formula that we just talked about, this is b times c downstairs, b times c. So it's b times c, so 3 times 2, and 3 times 2 is 6, correct? Times cosine, very much the same. Now a is 3 pi, right? A is 3 pi, and b times c now is 2 times 2, which is 4. Okay, now do you believe that these are remarkable angles? Let's find these each of these expressions. Well, the first one, let's find, how about we find the reference angles for each one of them? 7 pi over 6. Let's focus on 7 pi over 6. Where should I do this? How about I write it in black over here? So 7 pi over 6. What's that reference angle? Well, 7 pi over 6 is 6 pi plus pi over 6, which is pi plus pi over 6. Correct? So this is in the third quadrant then. This is in the third quadrant. Let me take you to to that picture to show it to you. So the angle is in the third quadrant. This is such an angle. That's 7 pi over 6. Correct? Why? Because it's pi plus pi over 6. It's a little beyond pi. Okay, and so what's that acute angle then? What's that acute angle? It's that angle minus pi, right? So it's the pi over 6. It's the pi over 6. That's the acute angle. Make sense? So how do you write this then? How do you write this then? This is 2 times cosine of, again, with a plus or minus, I need to determine that. Okay, so with a plus or minus, I need to find out what this sign is, and then times cosine acting on the acute angle, which is pi over 6. Correct? So one more time, trig function acting on an angle is plus or minus, which is to be determined. This is something we developed way earlier in the course. Plus or minus times the trig function, the same one, which is cosine in this case, times the reference angle of that angle, 7 pi over 6 in this context. And the plus or minus is going to be determined by where this guy lives and what the trig function is, or the sign of the trig function on that angle. Well, 7 pi over 6 lives in the third quadrant. Cosine of some angle like this, the cosine of an angle that angle lives in the third quadrant, cosine of such an angle is going to be negative, right? Because cosine is the first coordinate, so it's going to be negative. So I'm going to delete that and keep the minus. Okay, this is not 2 minus cosine pi over 6. This is 2 times negative cosine of pi over 6, okay, which is negative 2 times cosine pi over 6. All right, and now I need to find this guy, cosine of 3 pi over 4. Cosine of 3 pi over 4. Well, 3 pi over 4 is, let me do the same discussion. How about I move this a little down? Let's choose a different color. How about this color, blue? So I have, now I'm discussing 3 pi over 4. Well, 3 pi over 4 is um, 4 pi minus 3 pi over 4, right? I'm rewriting this numerator as 4 pi minus, sorry, this is wrong. So it's 4 pi minus 1 pi, right? Sorry about this. Minus 1 pi. So 4 pi minus 1 pi is 3 pi. And this is equal to 4 pi over 4, which is pi. So which is pi minus pi over 4. Okay. So this is in the second quadrant, as you might have expected. So this is in the second quadrant. That's the angle pi minus pi over 4, which is 3 pi over 4, right? Which is 3 pi over 4. And what's that acute angle? It's the pi over 4, right? It's the pi over 4. So what can we say then about cosine of 3 pi over 4? Well, cosine of 3 pi over 4 is that trig function acting on the reference angle, which is pi over 4, but still I need to determine the sign. I still need to determine the sign. Is it plus or minus? Well, in this context, since the angle is in the second quadrant, cosine is going to be negative. Cosine being the first coordinate of a terminal point belonging to this terminal, to the side, right? This terminal side. Any point that lives here has its first coordinate to be negative. So the cosine of such an angle, which is the first coordinate of such a point, is a negative entity. So I'm going to get the minus. I'm going to erase the other part. Okay. All right. And this is what again? This is what? So 2 times negative cosine pi over 6 times negative cosine pi over 4. The negative times the negative are going to be, it's going to be plus. So that's going to be 2 times cosine of pi over 6 times cosine of pi over 4. Correct? So what happens here is that these two guys turn into a plus. Agree with this? All right. And pi over 6 is 30 degrees. Cosine of pi over 6 is square root of 3 over 2. Pi over 4 is 45. Cosine of 45 is square root of 2 over 2. Okay. The 2 and the 2 can cancel. And we get square root of 3 times square root of 2 divided by 2. Square root of 3 times square root of 2 is square root of 3 times 2, which is 6, divided by 2, right? Because those two cancel, let's say. So square root of 3 times square root of 2 is square root of 3 times 2, which is 6. Remember, square root commutes with multiplication. So the product of the square roots is the square root of the product of the radicands, which is 3 times 2 in this case. Okay, so at the end of the day, all this guy is equal to square root of 6 over 2. Okay. All right, let's go to 27 through 34. Let's choose an identity, and let's choose 34 for this. So I have this quotient, sine of 4t plus sine of 3t plus sine of 2t. The whole thing is divided by cosine of 4t plus cosine 3t plus cosine of 2t is equal to tangent 3t. I want to show it, right? We want to verify this identity for all t's, as long as this expression makes sense. So 34, we want to show or verify rather, sine of 4t plus sine of 3t plus sine of 2t divided by cosine of 4t plus cosine of 3t plus cosine of 2t. We want to show that this is equal to tangent of 3t. Okay. All right. Very good. So obviously I'm going to start from the left-hand side because I have more ingredients to play with, right? And eventually, apparently, I'm going to keep simplify somehow and get all the way to tangent 3t. Okay. All right, so how are we going to do this? How are we going to do this? Certainly stop the video and try it on your own. The way I'm going to look at it is, how about I combine the sine 4t and the sine 2t together? Okay, I'm just trying. So any correct step is gonna let you move closer to that answer. Okay. So any correct step is correct. That's my point. Sine 4t plus sine 2t. I'm gonna combine the two. So I'm gonna use the sum to product formula that combine the sine of something plus sine of something else. Okay. And let's see what happens. So left hand side, this is equal to, I can rewrite it obviously as sine of 4t plus sine of 2t. I'm just using commutativity of addition. I'm just reversing the order of the last two, divided by cosine of 4t. I'm going to do the same thing downstairs. Cosine of 2t plus cosine of 3t. Okay. I mean, the only reason that I'm doing these two guys together is that because if we go back to those formulas, let me take you back to these. So if you go back to these formulas, from sum to product, you see here I'm adding them up and dividing by 2. I'm subtracting them and dividing by 2. So if the addition between them is even, then this thing is gonna be, I'm gonna kind of like simplify by 2, the numerator by 2, right? If the sum or difference between those guys is gonna be even, so this whole thing is not gonna have a quotient anymore. The denominator is gonna be 1 because I can still simplify. I mean, this is the observation I made over here. If you combine the two, that was my point. If you combine these two, the 4t and the 2t, you add them up, you get even, which is 6t, and if you subtract, you get even, which is 2t. So you're gonna somehow get, you're not gonna have a fraction of the sum. Okay, you're gonna have actually, in both cases, you're gonna have a denominator equals 1. Okay, so let me actually explain more than what I mean. Let's apply it. So what's the formula for this? We know that sine of, what do we call it, x plus sine of y, this is half times sine of x plus y over 2 cosine of x minus y over 2. That's the formula we're gonna use. Okay, and I'm gonna use it for this package. Okay, I'm gonna use it for this package. So I'm gonna use it for x being 4t and for y being 2t. So what do we get? We get half. So we get half times sine of x plus y over 2. And what's x plus y over 2? 4t plus 2t over 2 times cosine of the difference over 2. Cosine 4t minus 2t over 2. Correct? So that whole thing plus the existing sine 3t upstairs. right? I'm just adding this part. So that's the package I used for the numerator. As I told you, I'm going to do the same for the denominator. Let's go to that formula. So this formula is going to do with cosine of something plus cosine of something else. I want to transition to a product. Well, what's that formula? Cosine of x plus cosine of y happen to be twice cosine of x plus y over 2 times cosine of the difference over 2. Correct? So I'm using this for the denominator. And what do we get? So I'm gonna get half. Sorry, did I copy it wrong? So just a second. This is 2, right? Yeah, this is 2. My bad. It's a bad day today, so sorry about that. So 2 is here, and 2 is here, right? Okay. And that's a 2 here. So times cosine of x plus y over 2. So cosine of x plus y over 2, 4t plus 2t over 2 times cosine of the difference over 2, cosine of 4t minus 2t over 2 plus that cosine of 3t, right? Okay. All right, so again, as I said, my point was I did it for these two guys because, I mean, it's inviting because, look, the sum here is an even divided by 2, no more denominator. The denominator is 1. Namely, in this case, I have 4t plus 2t, which is 6t divided by 2. This whole thing is 3t, right? This is 3t. And this is how much? This is 4t minus 2t. So 2t upstairs divided by 2. 2t minus 2t divided by 2 is simply 1t. So this is 1t. Correct? Likewise here. This is 3t and this is 1t. Correct? So we get 2 times sine of 3t, as we said, times cosine of t plus sine of 3t divided by 2 times cosine of 3t times cosine of t plus cosine of 3t. Okay? All right, and now I observe that I can factor out sine 3t upstairs. I have this guy as a common factor upstairs. Correct? So I can push it outside. So I get 2. Let me write the sine 3t first. Sine 3t times 2 cosine of t plus 1, right? If you factor out sine 3t upstairs, you get this. Divided by I'm going to do the same. If you observe, you also have cosine 3t as a common factor downstairs, and that becomes cosine of 3t times 2 cosine of t plus 1. Makes sense? All right, and this group, this package and this package are the same. They are the same. So we can simplify by that package. We can simplify, obviously, as long as it's not 0, but the assumption here is that we're choosing a t here that doesn't make the denominator 0. So that denominator and this denominator are the same. So technically we're saying that t's cannot make this guy 0, and as such I can simplify. Once you simplify, we get simply sine 3t. We get sine 3t divided by cosine 3t, right? And what's sine of an angle times divided by cosine of the same angle? That's the same angle. This is tangent of that angle, which is 3t in this case. And this is exactly what they wanted, no? This is exactly the right-hand side. So that's exactly the right-hand side. And we're done with this. So you're gonna tell me, okay, how did you know that I should start this way? I'm not saying that that's the only way to do it, but that's my or the way I looked at it. I hope somebody else actually find it in a different way, just to reemphasize that there's no one way to do something, as long as you're doing a correct step is correct. Okay, so I mean, any step here is correct because I was using things identities which I know they hold, and it turns out that I realized here, okay, there's a common factor, and then everything seemed to lead to that conclusion. Okay. Um, let's go back to the book. Should I pick another one here? Let's do one more. So the 34. How about 30? This looks a little tricky, maybe. I don't know. So again, I haven't tried any of these, so we're doing them together. 30. Let's do that. So I want to show. So 30. We want to verify. We want to verify that cosine of 2x plus cosine of 4x plus cosine of 6x is equal to 4 cosine x cosine of 2x cosine of 3x minus 1. Okay. Again, as before, it looks like I'm transitioning from a sum of cosines to a product of cosines. Correct? And backwards, if you go right to left, you're going from product of cosines to sum of cosines. So you're gonna realize that the formulas we developed in this section are gonna be involved in this game, right? I'm going from sum to multiplication, sum to product. If you go from left to right, if you go right to left, you're going product to sum. Okay, so let's go from left to right. So let's start from left hand side. And here, if you add any of these two, it's gonna be even, so that's good. So let's start with these natural first two. Let's combine cosine 2x plus cosine 4x. I'm gonna write it as a first step. So I'm gonna add these two guys first. So I'm adding these two guys first. And what am I using? I'm using the formula that allows me to add cosine of theta plus cosine of phi. Okay, this is the Greek letter phi. So cosine theta plus cosine phi, if we go back to that thing, I'm talking about this, right? Cosine theta plus cosine phi is twice cosine theta plus phi over 2 times cosine theta minus phi over 2. Okay, so that's 2 times cosine of theta plus phi over 2 times cosine theta minus phi over 2. Right? So I'm using this. So I'm using this with, let's be specific what theta and what phi are. Well, theta is the angle that cosine is acting on, so that's 2x. And phi is the angle that cosine, the other cosine that's acting on, is 4x. Again, you could have taken the other way because addition is commutative. All right, that's fine. This is good. So I get, according to this, I get twice. This is in pink, sorry. So I get twice cosine of the sum of theta and phi. So 2x plus 4x over 2 times cosine of the difference over 2. So cosine of 2x minus 4x over 2. So that's this green bracket plus cosine of 6x, right? Excellent. So 2x plus 4x is 6x. 6x over 2 is, so 3x, right? One more time. 2x plus 4x is 6x. 6x over 2 is 3x. Over here, 2x minus 4x is minus 2x. Over 2 is minus x. So this is cosine of minus x. Plus that cosine of 6x over there, right? That cosine of 6x. Okay, cosine is even. Don't worry about this minus sign. So cosine is even. Cosine is even. So this is equal to, because cosine is even again. So cosine is an even function, allows me to not write this minus sign. So 2 cosine 3x times cosine of x plus cosine of 6x. Okay. All right, let's keep an eye on what we want. So let's keep an eye on what we want. We want, in the conclusion, I have cosine x, cosine 2x, and cosine 3x. Okay. So apparently we don't need the cosine 6x. In the conclusion, we don't have cosine 6x. So apparently we gotta do something about this. We gotta do something about this. And what is that? I mean, this looks like 2 times 3x, right? The 6 is 2 times 3. So this guy then can be thought of as 2 times what? 2 times 3x, right? So it looks like I can use one of these double angle formulas that we learned the other section and use it right here for this angle 3x, right? So cosine of twice an angle is one of those formulas I'm gonna be needing. Okay, and guess which one I'm gonna need? Remember, cosine has had 3 formulas. Let's recall them. So cosine of 2 theta, okay, was equal to, we had 3 formulas. One of them was cosine squared theta minus sine squared theta. This is one of the 3 formulas for cosine, the double angle formulas for cosine. And the other one was 1 minus 2 sine squared theta. Okay. And the last one was 2 cosine squared theta minus 1, right? So one of these I'm gonna need. But again, if you look at the conclusion, I see nowhere sine. I see no sine here in this expression. So I'm not gonna use that. I'm not saying it's strong, but probably it's gonna be a little longer route. So I'm not gonna use that because in the nature of the conclusion I don't have sine. I'm not gonna use that for the same reason. So I'm gonna use the last one. Okay, so I'm using the last one. So I'm erasing these guys. And I'm just gonna retain the last part. So I'm taking this as here, okay? So I'm using it now. So I'm using it here. And I'm using it for what? I'm using it for the theta as 3x, right? I'm using it for theta as 3x. Correct? Because cosine of twice theta, in this context I have cosine of twice the 3x. So the 3x is the theta. So with, I'm using this with the theta being 3x, right? Okay, so this becomes 2 times cosine 3x times cosine of x plus 2. I'm talking about this now, right? Cosine of 2 times theta is 2 times cosine squared theta, and theta is 3x, right? Minus the 1. Okay. All right. So this minus 1 is part of the conclusion. You see it? That's good. And then what? Somehow all this expression here, this sum is gonna be what we had what we had over here. It's going to be this guy, right? Okay. Well, I hope you see that I have cosine 3x as a common factor. Okay, which means I can factor out cosine 3x. I can also factor out that 2, right? The 2 is a common factor as well. So how about we factor out the 2? And then what do we get? If you divide this by what we just took out, so this guy is going to disappear, we get cosine x. And if you divide this guy by this entity, what we just took out, you're going to only get cosine of 3x. Agree with this? Minus 1. Minus 1. Okay. Again, keeping an eye on the conclusion. Keeping an eye on the conclusion. You see the conclusion? The top of the page, the screen? It's right there. So I have the minus 1. I have the minus 1. I have the cosine of 3x. This piece I have. It's right there. I have half of the 4, which is 2. So apparently this piece is going to give me the other 2. And it's going to also give me the cosine x, cosine 2x. Okay? So how does it look? Look, this is a sum. Apparently, I'm going to transition to a product. Right? This is a sum. Apparently, I'm transitioning to a product. So I'm going to also use one of the sum to product formulas. Right? So I'm going to also use one of the sum to product formulas. Let's do it. And this is going to be also between cosine and cosine. So it's going to be that green thing that you see here. Okay, it's also between cosine and cosine. Okay, so actually to save some time, I'm going to just take this and copy it. All right, let's copy this. Okay. So this time around, I'm not gonna use it for those theta and phi. I'm gonna use it for something else. Let's be very, very clear what these guys are. So no more of these. So who's theta and who's phi? Who's theta and who's phi? So cosine of theta plus cosine of phi. So apparently I can use theta to be any of these two, either x or 3x, as long as I use phi to be the other one. Okay, so let's choose theta to be, say, x. And let's choose phi to be 3x. Okay, and as such, we get 2 times cosine of 3x times, so times 2 times cosine of the sum of theta and phi, so between x and 3x, over 2 times cosine of the difference over 2. All right, minus that one. So far so good. All right, so this is equal to everything here is multiplication, right? So technically these parentheses are not needed because multiplication is associative. You can group them the way you want. You can drop the parent of these brackets. Okay, everything here is product. So 2 times 2 is the 4, the desired 4 actually, the one that we needed. Cosine 3x times, how about this? X plus 3x. How much is x plus 3x? That's 4x. 4x over 2 is 2x. Correct? So 2x. And how much is x minus 2x? X minus 2x is minus half x. Minus 1x. Minus 1x divided by 2. So something is wrong here. I certainly have a 3 here, right? Certainly I have a 3. Why I have a 3? It's the difference between theta and phi. So that's a 3. I don't know why I copied it. All right, so it's one of those days. So this is a 3. Okay. Again, now it looks better. X minus 3x is minus 2x, and minus 2x divided by 2 is minus x. So I get times cosine of minus x. Right, let me say it one more time. So x minus 3x is minus 2x, and minus 2x divided by 2 is minus x. Okay, and then I'm gonna carry this minus 1. Okay, so this is equal to, still I'm gonna use that cosine is even, so the cosine function is even, and as such cosine of negative x is cosine of x, so 4 cosine 3x times cosine of 2x times cosine of x minus 1. And this is the right hand side, remember? That's the right hand side, that's what we want. Alright, that's the right hand side, you see it? That guy. Okay. Alright, let's do one more problem in this section. Let's go to let's do one of these last two. Let's do 36. Change cosine of x plus h minus cosine of x to a product. So 36. So we want to change cosine of x plus h minus cosine of x, this expression, to a product. Okay. So this is a difference of two cosine functions, and one of the formulas that we developed before allows us to transition from the difference of two cosine functions to a product between, in this case, sine functions. Okay, so I'm gonna copy this and I'm gonna use it shortly. Okay, so that's the formula we're gonna be needing here. So we're using this formula with the x in the formula to be, okay, so what's x in the formula? It's the angle that cosine is acting on, and who's that angle that cosine is acting on? I'm talking about the cosine function that's acting on, which has the plus in front of it, right? So we're talking about the angle being x plus h then. Okay, so the x plus h in our context is the x in the formula. So the x in the formula is x plus h of our context, and the y in the formula is that x of our context. So the y in the formula is our x. Okay, so I'm gonna use this package to transition from the left hand side to a product. So left hand side, there's no left hand side actually in this case, so I'm talking about the expression cosine of x plus h minus cosine of x. Okay, so this arrow here is going this way. Okay, so as we said, the x plus h is the x in the formula, and the y, or the x in our context, is the y in the formula. So I'm gonna have minus 2 times sine acting on x plus y over 2, and x is x plus h, so it's x plus h, which is the x in the formula, plus the y, and the y is x over 2, right? Again, I'm rewriting what this means in our current context, times sine of the same thing but with a minus sign. So it's the difference between the x and y, the difference between this and this, which is the same as that one but with a minus sign. So I'm gonna have x plus h minus x over 2, right? Okay, and what is that? This is minus 2 times sine of what? X plus h plus x. This is twice x plus h over 2. And how about this guy? This is sine acting on x plus h minus x. Well, x minus x is 0. They cancel each other. So this and this are gone. And I have h upstairs and 2 downstairs. So h over 2. Okay. And did we answer the question? What's the question again? The question is, oh, it's right there. So the question is to change this expression to a product. And yes, we did. Okay. So this is a product between this factor, and that factor. Okay. All right. So I'm going to draw the line here for this section. This is the end of it.